I did get
Blair's
called
here.
out. Yeah, I got called out. Now I'm off work now, so Platypus, would you like to make a claim, or would you like to pick one of my claims that I made and attack it?
The specific topic of discussion was going to be the what you call it. I wouldn't call it an experiment, but what you were doing for uh, density and buoyancy, and
Okay, so
their
you
relation
wouldn't call it an
to.
experiment, right? So why does it not meet the criteria of an experiment? If I observe a natural phenomenon, okay, the water sticks to the surface of the earth sometimes, and sometimes it doesn't. So what's causing it to stick? And I manipulate two things, right? One at a time, obviously. And there's a cause and a co-cause, right, to what holds down the oceans. And I can demonstrate it because if you boil water at a temperature, causes the water not to stick to the surface, even though the surface is the bottom of a tea kettle or whatever. But you could also boil water at low temperature with low pressure. Is that true or not true?
Yeah, you can get water to evaporate by a change in pressure alone, yes.
And also a change in temperature alone, yes. All right, so what part of the scientific method did I skip?
Well, your experiment doesn't have anything to do with what you were trying to demonstrate.
What? Explain why.
Like you're answering the question, like you're pointing out that liquid water goes to the bottom of that container, which is great, but it doesn't do anything to explain why it does.
Because of the high pressure and low temperature. What do you mean? That's a perfect explanation that everybody who's ever made a cup of tea knows to be true.
One second here.
So where did I say something that's wrong? Or what part of the scientific method did I skip? Because I feel like you're arguing with like something that nobody on earth in their right mind would argue with. Or on the sea.
Because you drug it out in a discussion of what gravity was.
Well, if you have a different gravity, all you have to do is provide your presumed cause and hold my presumed causes constant and don't manipulate them or don't vary them in any type of way. So what is your presumed cause that you would like to manipulate?
I'm not even giving you one yet. I'm failing to get from point A to point Z with your demonstration. Your
Yeah,
demonstration
you're
has
failing.
nothing to do with why the water moves down toward the surface
Yeah,
of the
you're right.
earth.
You're right. You're failing to provide a alternative cause, and you have to admit that my cause is correct because we know about the rain cycle.
What you're showing has nothing to do with why the liquid water goes toward the surface of the earth. You're just demonstrating state change under different conditions. You've proved that you can boil water at a lower temperature if the pressure is lower. That's it. What does that have to do with the water moving toward the surface of the earth?
Maybe you're not getting it, right? Is the law of cause and effect true?
As long as you're ruling everything else out, sure.
No. The law of cause and effect is true always.
Yeah, but you don't always know that you've eliminated all the variables. You
Right.
just
That's why I'm asking you to give me your presumed cause, but you are failing to do that.
No, Larry, you're not picking up what I'm putting down here, dude. You
Well, that's a
brought this
baseless
up.
assertion. You can't prove that.
No, you brought this all up during a conversation of gravity and in a broader sense how both sides explain why things move toward the surface of the earth.
Okay,
And
just demonstrate yours.
what you brought up, it does absolutely nothing to explain why the liquid water moves toward the surface of the earth. You're just showing how to boil
But I can
water.
demonstrate it. I can demonstrate it by manipulating my presumed causes and show the water not sticking to the earth. So if I didn't do that, then that would be the cause of it sticking to the earth, unless you have an alternative cause, which you're failing over and over again to provide.
Cool. Let me ask it a different way then, because from what you just said, what's your presumed cause for the water moving toward the surface of the earth when it's liquid.
Seeking equilibrium because it's more dense in the atmosphere.
Okay,
Why else would rain fall?
Hold on. What is the definition of seeking?
Well, it's a colloquialism, right? And I probably shouldn't use that word. You are correct, right?
Yeah,
so
you probably
it
should.
appears
Let's use a scientific word.
it appears to be, how can I put it? To not anthropomorphize water.
I will give you as much time.
It appears
Because
to
that
be
is what you are doing.
reaching.
The
It
way you're
appears,
wording it, hold on, the way you're wording it is you're anthropomorphizing water. You're giving water sentience.
yeah, I've agreed with you already. I don't know why you're trying to interrupt me while I'm trying to find a better way to word it. It is approaching equilibrium.
Wait, okay, what does approaching mean?
Moving towards.
Are we talking about entropy now? What are we talking about?
Well, you know what equilibrium is, right? State of rest. So it's approaching a state of rest when the water's flowing.
For me, equilibrium is when a system has an equal distribution of energy, so that there's no energy exchange going on within the system anymore.
Right. So the water is pushing down, and the ground or the seabed is pushing up.
The water is going down, or the seabed is pushing up.
Both at the same time.
Okay.
I know that some people would agree with that, but
hold on. So not only does that not answer the question of why does the water go down, that now poses the question, how could the surface of the ocean be going up?
well, it's like the water is pushing down on it, right? So maybe I shouldn't say the surface of the thing is pushing up, but to answer why the water goes down, because it's more dense than the atmosphere. That's why it goes down. You still have no presumed cause of why you think it's going down that you can manipulate and vary and demonstrate.
No, I'm still trying to get, dude. I'm just trying to understand you and your explanation.
Well, you don't know why things fall down? Because they're denser than the medium they're in.
Cool. Show me where in calculating something to density it gives you any kind of a vector.
Wait, do you not know like mass over volume? Like the density of an object in a medium will make it go up or down.
Yes, and that's all.
So what are we talking about?
So where in that equation?
Exactly, that's all there is to it. We're not talking about equations. We're talking about cause and effect, right? You're making a category error. We're not talking about mathematical equations. We're talking about cause and effect. So what is your presumed cause that you can demonstrate?
Give me 10 seconds. I was told that if you and I started getting into it, I needed to at least alert Miggy.
Huh?
He wants to go tell Alpha that you guys are talking, I guess. I don't know.
No. Take your time.
Yeah.
Yeah, I really should word that different because it's not seeking equilibrium. It's moving toward equilibrium.
It's as silly as saying water seeks its own level.
Well, it's like a euphemism, right? It's fancy speech. I don't know why you're getting hung up on that other than diverting from the fact that you don't have a presumed cause that you can manipulate and vary to demonstrate what you're claiming is going on, because what you're doing so far is pretending like you're arguing against what we all know, which is an object in a medium will go up or down depending on its relative density between the object and the medium that it's in.
Hey, don't put words in my mouth. Hold on. Don't put words or thoughts or intentions in my direction when I didn't give them to you. Not once today have I given you any kind of an explanation for why the water goes down.
And
I heard your explanation for it and told you that you didn't address the question in the first place, so I don't know what you're talking about.
And you won't give an explanation either.
I would love to get an explanation from you.
No, you won't give an explanation as why water is going down other than some mathematical abstract. You're not going to do anything to demonstrate and manipulate your presumed cause because you don't have one.
No, this is you passing the buck.
Oh, so you do have one.
Understand you.
You do have one. What is it?
I'm trying to understand you.
You said no. You're disagreeing that you have one.
Is passing the buck right now. I'm still trying to understand your explanation and what it has to do with the water moving down. I'm trying to understand, Larry.
I don't think you are. I think you're avoiding the fact that you don't have a presumed cause like I do. I can manipulate
No,
gas pressure, and I
no.
can manipulate temperature, and the water will go up and down depending on what I do because the phase change makes the water extremely buoyant, and the buoyant force brings the water up. What is
Yes,
your presumed
great.
cause as to
And
why the
yes,
ocean is sticking to the surface of the earth?
that's good. You're stating all of that, and you're the one avoiding the fact that nothing you're saying has anything to do with why the water moves toward the surface of the earth. You still haven't gotten
Really? Really?
yes.
So you don't think things that are dense like rocks go down
Why would they go down, Larry?
because there's not enough buoyant force holding them up
How do you
until
calculate
they hit the
buoyancy?
ground.
Larry, what's the formula for buoyancy?
That's not my claim. Are you trying to, make me like back up some
So are you
claim that I
are
never
you
made?
okay, what version of buoyancy are you citing?
The kind that holds things up.
Yeah, that doesn't really answer my question in any kind of scientific
So
way.
does buoyancy displace and cause upward force
I don't
if an
know what this
object is?
I don't know what this buoyancy thing you're talking about is. Please tell me what buoyancy is and how you're calculating it, Larry.
You ever had a liquid with ice in it?
Is this going to be an explanation of what buoyancy is?
Yeah, it is. What do you think is holding up the iced tea, the ice in the cup of tea?
Well, I know it's because the density of ice is lower than liquid water or whatever liquid
That's
it's floating in.
That's another way of saying yes, Larry. You're correct. It's the buoyant force holding up the ice.
Okay, and how do you calculate buoyancy?
Do I have a calculator? What makes you think I'm calculating buoyancy?
Okay,
It's mass over volume.
so you're stating the buoyancy force, but you can't
It's
tell
holding
me.
up.
But you can't tell me how to like. Can I do a calculation to figure out if something's gonna float in the water before I put it in the water?
Why do you keep bringing up math when we're talking about science? We're talking about a cause and effect relationship. You keep diverting to math because you mathematically want to describe, what's going on and slap a label of gravity on there. But I have demonstrated that you can manipulate the cause, which is relative density, and you will see the effect of things going up or down. You cannot do the same. That's my claim. Prove me wrong.
Yes, you can see a relationship between the density of two things and which one ends up closer to the surface of the Earth, but that doesn't explain why the more dense one ends up closer to the surface of the Earth.
Because there's not enough buoyant force to hold it up.
How do you calculate buoyancy? How do you know there isn't enough buoyant force?
Why do you keep asking me to calculate when I can demonstrate? Calculation doesn't trump science.
Because I want to hear you say out loud, or at least stammer over yourself out loud, that you don't know how to calculate buoyancy. I don't even think you know what buoyancy actually is.
Look, you can mathematically describe things however you want to because math is a language. So you can describe Superman jumping over a building with a single bound, right? But I'm talking about demonstrable, falsifiable facts, and you don't have that. That's why you're deferring to abstract languages that you can describe things with. But I'm talking about falsifiable. My claims are falsifiable, and one of those claims is you cannot demonstrate gravity without manipulating buoyancy or density.
You are the one citing buoyancy. That is using the language of math. Buoyancy is a mathematical calculation. If you don't know how to perform it, then just say that.
Okay, I'm not performing any math. So what does that have to do with my claim that you can't scientifically demonstrate why water is sticking to the surface of the earth or why things go up or down without manipulating the relative density and buoyancy of the object and the medium that it's in?
Because things are pulled towards other things.
Prove it. Demonstrate it. Manipulate your presumed cause.
I can pick up anything that's more dense than the air around me and let go of it, and it will move toward the surface of the earth. Anything that's more dense than the air around it.
That's my claim. Thanks.
No, it's not.
You just said you can pick up anything that's more dense than the air around it, and it's going to go down because it's more dense than the air around it. That's my claim.
Because here's the funny part, Larry. Even the difference right now between you and me is even if I'm wrong, I can at least tell you why it moves toward the surface of the Earth. You can't even tell me why it moves toward the surface of the Earth.
Because
All
there's
you're
not
doing
enough
is
buoyant
using the
force.
word.
What's your explanation?
What does buoyancy have to do with a vector of any kind, a direction of any kind, or a force of any kind? If it's a
What does
force,
buoyancy have to do with a force? Buoyancy is a force. Do you not
okay,
know that?
I'm just going to say it out loud then. You won't talk about the calculation for buoyancy because you know it involves little g. You know
Actually,
that.
I just said that gravity is involved with buoyancy because you're mathematically describing it,
Yes.
right? So now
Gravity is
back it up,
involved with buoyancy. Yes.
back it up, manipulate your
Congratulations.
presumed cause of gravity. You can't.
Why? Because I don't have an object that has a greater mass than the Earth?
Whatever
Yeah,
excuse
of
you
course
need to
I
make so you can sleep at night. Yeah, I mean, make excuses all day. I don't care. You still can't manipulate your presumed cause and demonstrate what is causing it to go up and down. You just rub the word, gravity in the equation because you think that you can get away with a category error. We're talking about
No,
science.
Larry,
You
what
keep
just
evading.
happened?
You keep
Negative.
evading and going to math because you can't do what I'm asking you to do.
No, what just happened was I asked you for why it moves toward the surface of the Earth. You don't have an explanation, and your only out was to get me to say the big scary G word, which I
You're
finally gave to you.
you have psychosis because the reason why things go down is because there's not enough buoyant force to hold them up.
Great. And how do you calculate buoyancy? Because it's
You're
not.
in a category error.
Stop saying buoyancy force. Buoyancy is not a force.
Really? So what's
Yes.
holding up the ice
The
in the
water.
cup of tea?
The water. They're being set. It's just like oil and
So
water in a glass. They're separating into layers based on their relative density.
once again, that's my claim. Thanks for backing it up again. But if I push the ice
That's
down,
not your claim.
what?
Or at the very least, it's not an answer to your question.
Hold on. If I push the ice down, the ice is going to come back up. What force is that that's making
Wait a
it
minute.
move?
Hold on. Wait, what did you do to the ice to make it go deeper in the water? You
You
applied a
push it
what?
down. You push
You
it
applied a
down.
what? What did
I
you apply?
applied a force. What force is
Yes,
bringing it back up when I let go?
the water.
Is that the name of the force? Tell me more about this force called the water.
Water is not a force. Water is more
What you just
dense than
said.
ice. Water is more dense than ice.
So what? Okay, in order for an object to be in motion, there has to be a force, right?
Yeah, right now, what you're using is a solid and a liquid, and the liquid being more dense than the solid. You get the benefit of the liquid being able to, instead of having two solids stacked on top of one another that are different densities, they can't really move around one another to have the more dense one go closer to the surface of the Earth because of something called friction. And the fact that they're all they're in a solid state. They're all atomically bound together with the weak atomic force. But your ice and water is different. The water, A, is the more dense thing, and B, is a liquid. It's not bound so tightly. It's more free to do things like, I don't know, flow around the ice or under the ice. That's how it's able to do that.
You're bloviating. I asked, what is the force that moves the ice from the bottom of the cup when I release the ice by moving my hand out of the water? What is the force that brings the ice to the top of the cup?
Nothing is bringing the ice to the top of the cup. No force, anyway. What's happening is
So
a
how does an
force.
object move without a force acting upon it?
Excuse me. What's happening is a force is bringing the water down. It just so happens that as the water comes back down, it occupies the space that the ice was in because it's less dense. That's all that's
So
happening.
if it's less dense than
Dude,
the ice,
you're doing a different version of the helium balloon argument. The helium balloon isn't going up. The air that's more dense than it is going down. It's the same thing, same argument.
So for an object to be in motion, there has to be something that acts upon it. What force is acting upon the
hold on.
ice?
You're halfway there. You're halfway there. Yes, there does have to be a force acting on it. So we agree that there is a force there.
What's the force?
Why don't you tell me? That was my original question to you. You know my answer to the question. What's yours?
Well, no, I keep asking you what force is bringing the ice from the bottom of the cup filled with water?
You're really not gonna tell me what force it is.
It's the buoyant force.
Buoyancy is not a force.
Then how does the ice move without a force acting upon it then?
Now we're going in a circle. The ice isn't
Well,
the
I'm
thing that's
asking you,
moving.
can you
The
not
water
answer?
is, excuse me, the ice isn't the thing that's moving. The water is the thing that's moving.
Oh, it's all relative now. So the ice is at the bottom of the cup. I pour water into the cup, and now the ice goes to the top of the cup, but it's not the ice that's moving. It's an illusion, right? Don't trust your eyes? Is that what you're going to say?
I wouldn't call it an illusion, but it is definitely wrong to say that the ice is moving up under some kind of
Really?
force.
Even though it's measurable. You could put it in a measuring cup, right? It's at the bottom near the half the cup marker. And then you pour water into it, and it goes all the way up to the top. But it's not moving, though, right?
Yeah, isn't it crazy how when you put the ice cube in the cup and you put your finger on top of the ice cube, there's no force pushing on your finger? But then when you add the water, suddenly there's a force.
What force is that?
It's the force of the water being more dense than the ice moving down to the bottom of the cup. The ice just
Can you
gets
cite your
pushed out of
source
the
for
way
this
because
force?
it's less dense. That's all
Can
it
you
is.
cite your source for this claim that you're making?
You're the one telling me that things separate because of density, Larry. It's literally what
So
you're
no,
saying.
so no, you can't.
I'm citing you.
A citation.
I'm repeating what you said
I'm the citation? Cool.
because I'm
I don't think
repeating
I've ever
what
been
you
a
said.
citation before. I don't think I've ever been cited before. That's fucking cool. Thanks, bro.
Okay, continue.
What is the force that moves the ice from the bottom of the cup to the top of the cup when water is introduced?
The ice is not being acted upon by a force. The water is being acted upon by the force. It just so happens that the ice is less dense and it gets moved out of the way as the water tries to move toward the surface of the earth.
That's my claim. Thank you. Do you agree with me?
Again,
That the water is more dense than the
Larry,
ice, and the
everything that
ice
I
is going to
just
be
said,
pushed up.
everything that I just said is an observation. It's not an answer to why.
Wait a minute.
You've got the first
you
two
add,
steps. You got the first two steps of the scientific method down pat. You have the observation and you have the question. You've got those down handedly. Where you're stumbling is everything that comes after that. You're not answering the question of why. You just keep making the same observation over and over again.
okay, so when there's ice in the bottom of the cup, obviously the medium of the gas is not going to have enough buoyant force to push it up.
Yes.
So when I introduce,
the
can I finish?
Yes, the
Or can I
glass is
finish?
full of air. Yeah, I know. The glass
Right.
is full of air.
So when I add the water, right, the water is much more dense than the ice. So the buoyant force is going to push the ice up.
Stop
You're saying
calling
the
it
water
buoyant
is the force.
Buoyancy is not a force. I'm just asking you to
Buoyancy
say
is
it
not a
right.
force. So what force is moving the ice then?
This is the fourth time I'm not going to do it again. The ice is not moving up. The water is moving down because it's more dense than the ice and it is in a liquid state and therefore has less friction. The water pushes the ice up out of its way.
So when I say the water is more dense, it's equivalent, it's synonymous to say the ice is more buoyant. Is that correct?
No, it's not. The correct thing to say is the ice is less dense than the water.
Okay. So the ice is less dense, which means buoyant. Those are synonymous, right?
No,
Buoyancy.
density and buoyancy are not synonyms.
Oh, no, they're antonyms.
No,
the opposite.
one's a property of a body of matter, and the other one is how two different things interact with one another. under a force. They're not really as related as you think they are.
So buoyancy and density aren't related.
You got to know the density of an object to do any work with buoyancy or calculating it, but like buoyancy is not a property of matter. Density is.
So mass over volume is not describing matter?
That's okay. Again,
Okay.
for the third time, you've cited the formula for density, which is great, fantastic. Why can't I get you to post the formula for buoyancy? Why can't you type that in the chat down here?
Because it doesn't prove anything. A formula is a mathematical description, right?
Excuse me. I didn't ask you if it proved anything. I asked you, why can't you put the formula for buoyancy down here in the chat for everyone to see?
I'll do it when you cite your source that water's the force. Okay, how about that?
How about this? I don't need you to do it. I'm going to go and grab it and put it down there myself. But for the record, I know exactly why you're not posting it, and it's cowardly.
Well, I said I would do it if you just, backed up your claim that water is a force. That's what you said earlier.
Right. So you're not actually going to do it. You're passing the buck.
Because you can't do yours. Because you can't do yours. I'll do it if you do yours. I will.
Not only are we going
it.
to get to the point where I do mine, because again, I'm still trying to get you to answer your question. I'm going to go ahead and do the work that I was asking of you for you. Give me a couple of seconds. I got to go dig it up.
Okay, you can post a mathematical formula. It still doesn't negate the scientific method where you can demonstrate that high pressure will hold down water. Also, low temperature will hold down water. You can't argue against this. I don't know why you're pretending to. You say that it's gravity. All you have to do is hold my presumed causes as your constants. So you can't manipulate buoyancy or density to demonstrate your claim that it's not buoyancy or density.
No,
you're holding it down. Hold on, I'm in the middle of a sentence. All you have to do is manipulate your presumed cause, and let's see the water go up and down. Like I can do.
Your arms are going to get tired from moving these goalposts, dude. I had a
How's that a moving of the goalpost? You're making a claim that it's not.
All of this started with me asking you why the water moves toward the surface of the earth. That's it. You still haven't
it's more dense. I've already told you, it's more dense than the medium that it's in.
Show me where the formula for density gives a vector.
It doesn't, and that's not my claim.
Right, so then it's not the answer to your question, Larry.
But I can demonstrate the water going up or down. Can you do that?
You can demonstrate, dude. Again, I'm asking you, why is the water going toward the surface? And you're saying it's density. I'm saying that doesn't answer the question. And then you're answering that by giving me all these different ways that you can change the density of H2O. You can turn it into a gas. You can bring it back to a liquid. You can put it in a container. You can put it in a vacuum. Great. You keep showing me different ways to demonstrate density. You're not answering the question of why it moves toward the surface of the earth. That's all I want.
See, I'm not demonstrating density. I'm demonstrating relative density. It's also known as specific gravity. I understand that you don't like the fact that I can demonstrate my version of gravity, also known as relative density, and you can't demonstrate your version of gravity, which we don't even know what your version of gravity is. What is your definition of gravity, sir?
Is this you not answering the question again?
So I'll answer your question if you answer mine.
Dude, I'm regretting not actually taking I think you Jedi mind tricked me into not formally taking this into the arena, because you wouldn't be getting away from your question right now.
I don't know what an arena is. What are you talking about?
Yeah, never mind. It might be before your time.
You're talking about the 24/7 arena?
Of course I am. What do you think I was talking about? The fucking Roman Colosseum?
Well, I don't know what you mean because I can't read your mind. So if you say something, I might have to ask a clarifying question. Like when you say gravity, what are you talking about?
When you say relative density makes the water move toward the surface of the earth, what are you talking about? You know, the original question that made me want to talk to you in the first place? And you knew is what I was going to ask you?
Water in its liquid form will move down until it reaches equilibrium. And that might be a state of rest. Once it reaches a state of rest, it can't move down any further. Like a riverbed, swimming pool,
Move down.
it goes down because it's more dense than the atmosphere. What would you expect it to do? You expect liquid water to float?
I don't expect it to do anything. I expect you to show me an answer to the question.
Why does water go down? Because it's
Why
more
does
dense
water
than
move
the
toward the
atmosphere.
surface of the Earth?
Because it's more dense than the atmosphere around it. The
That
atmosphere
does
can't
not
hold it up.
answer the question, Larry.
How does it not?
Because nowhere you're saying density, density. Cool. Show me where density gives a vector.
That's not my claim.
And while you're at that, hold on. I'm sitting on a couple of things. I'm going to dig them out one at a time. Right now, we're going to pull out the curveball of while you're explaining why things move toward the surface of the Earth with density, I also want you to explain why they accelerate toward the surface of the Earth with density. What do you have to have in order to have acceleration, Larry?
I don't know what.
What's the necessary antecedent to acceleration?
I don't know what.
Force. You have to have a force. You have to apply a force to something in order for it to accelerate. What's the force?
And then you go and claim a pseudo force and wreck yourself.
It's a 101 right now. I don't know if you know. Yeah, so he hasn't told us what his version of gravity is. I have all but demonstrated it for you on camera because we all know what happens when you put ice in a cup or an apple in a pail of water and you drain the water, the apple goes down. You put the water back in, the apple goes up. I don't know what that has to do with mass attracting mass or the bending and warping of space-time. All I'm asking you to do, which is a simple question, can you please demonstrate gravity without manipulating buoyancy or density, please?
You're not asking me anything, Larry. I'm the one who asked you a question in the first place, and you still have not answered it.
So tell me what's wrong with my answer. What's missing or incorrect?
Your answer doesn't explain why it moves toward the surface of the Earth. Why?
Because the lack of buoyant force, that's why. How's that not an explanation?
How do you calculate buoyant force, Larry? How do you calculate buoyant force?
That's not my claim. That's not my claim. I'm not saying I know how to calculate buoyant force, and then you're saying,
Larry,
hold on, you're cutting me off. You're cutting me off. I was talking, you're cutting me off. I didn't claim I know how to calculate the buoyant force. And then you say, oh, show me. You're saying, why don't you show me this mathematical thing, right, that you're not even claiming that you can demonstrate? I'm claiming I can demonstrate a cause and effect relationship of why objects go up or down, and you're saying, why down? What do you expect, to fucking fall sideways?
No, all you're demonstrating is the cause and effect relationship of relative density.
Exactly.
That's it. Explain to me what relative density has to do with the more dense object moving in the direction of the surface of the Earth.
Because you can manipulate the relative density and make it do that or not do that.
Larry.
Just because you don't like my answer doesn't mean that I didn't answer the question. That's for the audience to decide. So why don't you keep your mouth shut about what the audience should believe and stop hijacking the narrative and be concerned about narrative control? Why don't you be concerned about you giving me a presumed cause that I can manipulate to make objects go up and down like I can do that you can't do?
I'm happy that you can demonstrate relative density.
I'm happy that you can't. Demonstrate your presumed cause. You never will give me a presumed cause that I can demonstrate.
That's because that's not.
You don't have one.
That's not the discussion at hand, Larry.
Absolutely, it is. That's why I'm saying it's coming out of my mouth.
If you're going to point out to Heretic that this is the one-on-one, this isn't just you and me talking. You've now established this was the one-on-one. The topic of discussion for the one-on-one was your quote-unquote demonstration and what it has to do with gravity and or objects moving toward the surface of the Earth. That's it.
Okay, what's your point?
My point is you still haven't answered the question.
Another hijacked narrative. Why are you so concerned about the narrative? Can the audience not craft their own narrative from our discussion? Why do you feel the need to use the power of suggestion and hypnosis to hijack the narrative? Why do you do that?
So I'm hypnotizing you now.
No, the audience, you can't hypnotize me.
I'm hypnotizing the audience now.
You're attempting to construct a narrative that I haven't answered the question when obviously I'm on record answering the question. And then you're saying that I didn't answer the question. Just because
Yeah.
you don't like my answer doesn't mean that I didn't answer the question.
You're using tactics, no doubt.
Mary Mom, with all due respect, this is a one-on-one that we arranged for a couple of hours ago.
So you don't like it when we try to hijack the narrative? Although I agree with you, it is a one-on-one, but sometimes we get excited.
You said it first, not me.
Yeah. Obviously, it's a one-on-one. We're trying to be quick about it. So if you don't have any sort of presumed cause and you just want to attack my presumed cause, even though obviously buoyancy and density are a thing, you can describe it mathematically however you want to, and you can slap gravity on there. That's the pin the tail on the donkey fallacy. Go ahead, dude, knock yourself out. But until you give me your presumed cause, my presumed cause, two causes, right? It's the relative density, right? So it could be whatever is causing it to go up or causing it to go down, right? You know what my causes are. What is your presumed cause? And until you can answer, I think we're done.
No, you know mine. I'm not entirely sure I know yours. I still have not been able to glean that from what you're talking about, Larry.
So what is yours?
Yeah.
So you said that I know,
no,
which is
hold
the
on,
basis to
hold
say so.
on.
Obviously, I don't know.
Hold on.
What's your
Hold on.
presumed cause?
Hold on. This is where I go full disclosure. Because I subscribe to the notion that mass attracts mass. However, the space-time warping thing, I don't understand that version of it. B, I don't think I ever will. I try, I really do. The thing that I see is mass attracting mass.
It has nothing to do with the volume?
Now, I understand that that's observing what happens without necessarily explaining the vehicle behind it.
Yeah, what's the mechanism? You know what my mechanism is?
I really don't.
You don't know why the ice goes down when you drink all the tea?
Larry,
You don't know?
Larry, the only two words you've given me so far are density and buoyancy, and neither.
No, I said relative density, also known as specific gravity. You're not listening. You just don't like my gravity, but you don't know how you can demonstrate that it's wrong or give me an alternative cause. If you have an alternative cause, I'll be quiet. Please tell me what it is.
That's not the topic of discussion that I told you
Of course it
to
is.
talk about. It's not.
Of course it is.
It's not. I needed you to explain how you were demonstrating why things move toward the surface of the Earth. And you haven't gotten
It's obvious. Mass over volume compared to the mass over volume of the medium that the object is in. If it's higher, what happens? It goes down. If it's lower, it goes up.
Okay, so if I take two spheres and put them on the table next to one another horizontally, but one is more dense than the other, what happens to them?
I'm not talking about horizontal attraction. That's your game. I'm talking about why do things go up or down?
No, hold on. That was. I want to be clear. I wasn't even going there with that. I was literally just talking.
You just brought it up. You literally just went there.
I'm not talking about those two spheres attracting one another. I was talking about what happens to those two things with different densities with respect to moving toward the surface of the Earth.
Why did you say on a table side by side?
Right. They're still, one is more dense than the other. So what's different here? Why doesn't one of them move more toward the surface of the Earth than the other when they're side by side?
Because they're on a table. They're not moving anywhere past that table unless the table's really weak or those things are really heavy. I don't know why you asked that.
And I was going somewhere with that. It's 2:45 in the morning.
Go ahead.
Two objects, or in your example, and two objects where one is in a different state of matter, solid and liquid, and how they act when they're with one another. That's the wrong way to put that. When the solid is in the liquid, the way that they interact with one another has something to do with a force. And you actually demonstrated that when you pointed out that you can push the more buoyant object under the surface of the level of the surface of the, oh my god, I can't talk. The surface of the liquid. And then it'll pop back up on its own when you let go of your finger. That's great. In order for it to do that, there has to be a force being applied somewhere. And you have not described a force. Density
So
is
the
not a
buoyant force.
Is
You said
density
water
one?
force.
Maybe this is where I'm getting confused. Is density a force? Yes or no?
No, I don't think it is.
No, I would agree with you. It's not a force. Okay, so we're not talking about density as an answer to your question. So the only other word that you've used to answer the question is buoyancy. Now, is buoyancy a force?
I believe it is.
I am starting to agree with you more. Cursory search of the internet, I may have been wrong on that one. It does look like people refer to it as the buoyant force. However,
Well-
how do you determine buoyancy?
Through demonstration.
Can you make any predictions about buoyancy?
Yeah, if mercury is more dense than steel anvil, then the steel anvil will float.
So you got to put the anvil in the mercury, correct?
Well, obviously.
Okay, and with respect to the surface of the Earth, what direction does the anvil go?
Away from the surface.
Why always away from the surface?
Because you did not spin it.
What?
Because you did not spin it. If you spin it, it'll be like a centrifuge and it will go towards the center as opposed to going away from the ground.
Well, yes, because you're going to be applying a force to the
A
mercury
pseudo
and
force.
pushing it
It's
out
a
of your
pseudo
way.
force. It's a pseudo force.
No, that's a force. It's not a pseudo.
Centrifugal force is a pseudo force. Look it up. Or I'll cite my source. Do you want me to cite my source?
How have I been here 7 years and I've never heard the expression pseudo force? Unless somebody was just calling gravity a pseudo force or something. Hold on.
Were you wrong? Centrifugal force is pseudo force.
Is this synonymous with a fictitious force? Because I'm seeing a lot of stuff for fictitious force.
Well, pseudo and fictitious are synonymous, aren't they? I'm pretty sure.
Hold on, Platypus might be learning something here. Oh, okay. It's yes. So, like the Coriolis force is a fictitious force. So the centrifugal force is also considered a fictitious force.
Tell me about this Coriolis force.
It just was me being the idiot that I am and being lazy because it's almost 3:00 in the morning. I went to Wikipedia of all places. It's got a little go to the Wikipedia page for fictitious force. It's got a little Coriolis diagram right at the top.
That's funny because what does a spinning merry-go-round have to do with an object flying over it? What force does it enact upon the object or anything? It's ridiculous. The only force added to the ball was the pitcher or the quarterback that's throwing the ball.
Oh, you gave me some reading material. I'm gonna, hold on. We're gonna take a rain check on this. I'm gonna have to read up on fictitious forces. It's also 3 in the morning. To be continued. I'll grab you either today or Sunday before I got to go back to work on Monday. That all right?
Well, tomorrow morning would probably be a good time.
As in Saturday morning?
Yeah, that's what I meant. Saturday morning.
I can't because I have to go and play Dungeons and Dragons.
Okay, have fun. Cast a dragon skin spell.